Hi viewers, this is Sri Ramlu. So today's topic is concept of magnetic field and magnetic flux. So first, magnetic induction. So magnetic induction is also called as magnetic field or magnetic field strength. Consider a positive test charge q naught is moving with a velocity through a point P as shown in figure. So in the figure there is one test charge is moving. See, this is the test charge at point P and it is moving in this direction. And here initially the field direction is like this. Okay, so particle is test charge is traveling in this direction with a velocity v, making angle theta with b only, making angle theta with b. So b direction is given in this direction along the y direction, and then force acts in this direction. Okay, so that is according to Fleming left hand rule only. We can easily decide in which direction force acts on the particle when it is moving with a certain angle. If there is no angle, the force cannot act on the particle, that is we know. Next point, if this charge experiences a sideway deflecting force, then we say that there exists a magnetic field at that point, right? Suppose the particle is suppose it is traveling in this direction. Instead of traveling like this, if it deflects sideway force like this, then we can say that on this test charge what is, there is a magnetic field is acting. That means magnetic force is acting. Okay, next, the field is defined by a vector quantity B called as magnetic induction. Here see, along the y direction B is so that means the field direction is like this. Particle is traveling in this direction with angle theta. Next, if a positive test charge q naught moving with velocity v through a point P in magnetic field experience a deflecting force F, then magnetic induction B at P is defined by the relation. So there is a relation between charged particle Q and with velocity VB. So that is this one only. F is equals to Q naught into V cross B. So actually V and B both are vector. So their vector product gives the vector. So we know force is a vector. Alright. So vector is equals to what? So force is a vector is equals to Q naught. It is a scalar into V bar cross. Actually bar we have to keep on them. V bar cross B bar. Suppose if you remove the cross product, then we have the formula, that is what? QVB sin theta. For the cross, sin theta will come. If there is a dot, then cos theta we have to write. Okay, for cross sin theta, for dot cos theta. So for dot cos theta. And from this relation, we can write a B value as F by Q naught V sin theta. So that means keep B this side only and sin theta Q naught we bring this side, these three things divides. So we know why, because we are not children. Okay, next, see, so by using this formula only there is a definition. So see what is that definition. The magnitude, so see the B is equals to F by Q naught V sin theta. So V sin theta is a component of velocity. V cos theta is also a component of velocity. Okay, V sin theta is a component of velocity. So velocity component we call. The magnitude of magnetic induction at a point is the ratio of the force moving charge at that point 2 means division line, to the product of charge and a component of its velocity along the direction normal to the induction is called as magnetic induction, right? So once again, definition. So here, what magnitude of force by product of test charge and velocity component, that is only its definition. But a division line is defined with a word 2, right? So you don't forget, division line is defined by a word 2. This 2 indicates division line. Once again, listen the definition. The magnitude of the magnetic induction at a point is the ratio of, from here only, ratio of the force on moving charge. So this force is acting on the moving charge only. Moving charge at that point 2 means division line. 2, these two comes product of the charge and component of its velocity. So component of its velocity along the direction normal to the induction is called as magnetic induction. So this is the definition of magnetic induction. And see the next one, magnetic flux. Magnetic flux is denoted by a symbol or a letter phi. And definition is, see, the total number of lines of induction passing through a surface is called magnetic flux through that surface. Here, total number of lines of induction. See here, it is a surface. Through this surface, how many magnetic lines are passing? So that number is called magnetic flux only. Once again, for example, suppose let it is on surface is considered, and let the lines of forces are this much. See how many lines of forces are there? 1, 2, 3, 4, 5. Out of 5, how many are passing through the surface, this body, through this circle? 1, 2, only 2. So magnetic flux is simply 2. Okay, so that is the total number of lines only. Number of lines, how many lines are passing, that is. See once again definition. Total number of lines of induction passing through the surface is called a magnetic flux through that surface. For this here, consider an element of surface area represented by vector area ds. ds is a vector area. So generally area is not a vector. When it is vector, when it is multiplied with the unit vector, then only it becomes vector. Okay, as shown in figure. In this figure, see. So, and this ds always we have to denote perpendicular to the considered surface. Suppose if you have considered here small area, so and its area is ds, but direction you must denote it perpendicular to it, normal to it. Perpendicular means normal. Suppose it makes an angle theta with the magnetic induction B on that area. So like this. Then the scalar product of B dot ds will represent the number of lines of induction over that area, that is a magnetic flux d phi over ds is. So small area is taken, then number of lines are so small, means flux is small. And flux is a scalar quantity, so that is why it is a vector, and B is also a vector. We must take dot product. So dot product is taken. So d phi is equals to B dot ds. Integrating on both sides. For integration here differentiation cancel. So here all integration will remain. So this is the formula of flux. What is that? Flux phi is equals to integral B dot ds. Okay friends, don't forget encouraging me. Thank you.